let's start by writing ourselves a linear time algorithm. So public static e in return Boolean. And this is basically going to just mimic the contains method, which would search a array to see how array list to see if an item is in it or not. So we're going to say, hey, does this for this array list is E item in it? Now this is a linear time algorithm. So we'll do this as an example, and then we'll start looking at the individual functions in the array list to basically get a look of how long each of these take. So public static boolean in, so we're going to assume that it isn't in the array list and return false. So what we'll do is that we need to check and see every item if it is that item that we're looking for. So for int I is equal to 0, I is less than list.size. For int I is equal to 0, I is less than list.size. And we'll just simply say if list.get the ith item is equal to the item that we are searching for, congratulations, we can return true. Now, again, this is one of those cases where we are going to have to slow it down despite how big it is. So, let's go ahead and search for, so we're adding positive numbers, so I'm going to just look for a negative number in there. And I'll explain why in a second. But notice that 10,000, it takes 2 milliseconds. 1. At 100,000, it takes about the same time. No time whatsoever. In other words, that's error time. Okay, maybe 8 seconds now. 44, not seconds, milliseconds. And that pause wasn't the milliseconds. That was it just taking that much longer to build an array list. And then finally, we're getting some growth there. That looks to me, but it only looked to be linear at those last two, which doesn't really give us a good, accurate representation. Now, the reason I'm doing this -13 is that I'm controlling so that we are always in a worst-case scenario. Specifically, what I'm doing is that I am looking for, the worst-case scenario is that the item I'm looking for is the very last item in that list, right? Because that's going to be the last time I check, or it doesn't exist in there at all. So we care about the worst-case scenario because we're pessimists at heart, because of Murphy's Law. What can go wrong will go wrong, and you need to know how well and we really care about how well this program will actually work under the worst-case scenarios, because those seem to crop up a whole lot. Average case also is often the same as the worst case, but we care about that. In other words, how it will perform most of the time. And typically, and that might be better than the worst case. Sometimes it's just as bad as the worst case. What we don't really care about is the best case runtime, because that's not very informative, because I can always come up with the best case scenario. Best case scenario for this one is that's the first item I'm checking. What's the average case? Somewhere in the middle. See, took no time at all to find the very first item, even with that long one. So I'm trying -13. Okay, so but still I want to slow this down considerably, so let's go back down to 1,000 items, and what I will do here is add in my for loops over here. Now this is still, with the for loop over here, this is still going to be a linear time algorithm, because this for loop will, if you're reviewing this, you'll be like, wait, it's a nested for loop. So this is a message to you when you're reviewing. This is for the future. Yes, it's going to be a nested for loop, but this for loop is going to run a constant number of times, even if that constant number of times is fairly big. So it's going to operate the same amount of times no matter what. This loop is going to operate the same amount of times for each individual loop. Out. Nothing. So 541, so that we've considerably slowed this down. If we go down to 100, maybe we'll get it down to 54. 60, that's close enough, right? We're getting some jitter in there because the operating system will schedule things in a certain way. The Java virtual machine will schedule things. So there will be some jitter. That's perfectly fine. It's not going to run the same amount of time, right? Sometimes it takes forever to load up that YouTube video. Sometimes it takes no time at all. Just depends on what your computer is doing or what the server is doing. Now, this one will take 10 times as long because I increased the size by 10. Boom, there we go, right? So this is clearly a linear relationship. Having 10 times as many items to search means that it's going to take 10 times as long. If I were to half this, it should take half the amount of time, right? That was multiplying by 5. If I were to half this, I'll fix that in post. I'm not going to fix it in post. So now it took half the amount of time.